Greetings to all. Here, the session is described for the intermediate chemistry. This will be very much fetching for your international entrance and competitive exams as well. India is conducting entrance exams into IIT and NIT stream. That is the technical domain all across the nation. And it will be conducted twice a year in the form of JEE Advanced. JEE means examination. NEET exam will be conducted by Government of India by National Testing Agency. That will be for medical stream. Again, it is applicable to all across the nation. Telangana and Andhra Pradesh governments are conducting examination called MSET. This is the entrance or admission into BTech or engineering stream. That is again technical domain. In addition, government is organizing so many government job examinations. So those are called as a competitive exams. Among all the exams, one common criteria will be there, that is the general studies question paper. That will be common for all the disciplines, so that in the general studies you can find general science as the content. The session what we are discussing is very much useful for your that kind of preparation. Let's enter into our today's session. Write the chemical formula for. Here IUPAC nomenclature is provided. We have to go for their chemical formula. IUPAC stands for International Union for Pure and Applied Chemistry. As per the IUPAC protocol, here the name is provided. It should be converted into a chemical formula. The first compound is amine tetra-aqua chromium 2 ion. Amine means it is the ligand. Tetra-aqua, 4 water are there. Chromium is the central metal in this, and 2 is the oxidation state around the central metal, and it is the kind of ion it mentioned with. Then amine sulfato. Amine means NH2, sorry, NH3. NH3 will be there, that is the neutral ligand. Sulfato means SO4 will be there, and the chromium, it is mentioned with the chromium too. This is the way two compounds are provided, the chemical formulas to be assigned. Amine means what? Already we just gone with. NH3 is called amine, which is a neutral ligand. Ligand is nothing but electron pair. At least one electron pair can be donated to the central metal through the coordinate covalent bond it should give. Okay. Tetra-aqua. How many water are required? Tetra denotes what? 4. 4 water to be mentioned, and it is said to be chromium. Chromium complex. So this is the entire sphere. They are saying that it is the ion. What they mentioned, the charge is indicated in the Roman numerals as a 2. So here 2 indicates chromium is accompanied with the +2 charge. That to be mentioned as +2 over the entire complex, being it is the ion. So it either taken like a H2O taken for NH3 or else NH3 H2O taken for, both are fine only. But there is a condition that whatever oxidation state they mentioned around the central metal, that should be satisfied. And how many ligands they mentioned, we need to accompany. And the central metal to be mentioned. This is the way chemical name can be transformed into chemical formula. Move on to another compound, amine. Again, mention only NH3. Amine means here only one amine they are saying. Sulfato. Sulfato means SO4 will be there. Always SO4 is accompanied with -2 charge. Everybody aware that, because sulfuric acid, if you take H2SO4 will be there. H2 means 2 H plus ions are there. SO4 means -2 charge will be there, right? So that it is the negative ligand. Chromium, again it is the complex of chromium. They mentioned with the +2 charge on the chromium, the Roman numerals, so that here chromium sulfato is giving -2 charge, which is counterbalanced by +2 charge on the chromium. That is perfectly balanced, and being it as a neutral complex, need not to mention any charge over the coordination sphere. Chromium SO4 NH3. This is the way you can write its composition, and either SO4 NH3 or else NH3 SO4, both are fine with the complex formation, right? This is the way whatever names are provided to be converted into a chemical formula by following IUPAC protocols. This is the way question number 1 can be answered. It is the kind of new conversion. Move on to question number 2. It is collected from Cambridge Assessment International Education, and it is the part of corrosion. The topic regarding the corrosion application based question, it is steel consists mainly iron. So let me assume this is the entire device which is made up of iron. Iron forms rust when it is react with water and oxygen. Here, rusting of iron is the common thing. Rusting means what? Everybody aware about that one. Let me give the simplest example. Take your grill. At your home, you have a grill. So by continuous contact with water, what happens? The grill will become a kind of rotten material, so rusted material. So a kind of layer formation is possible. After few days, the breakage of grill is possible. That is purely because of corrosion. So deterioration of metal due to the presence of either water, oxygen, any other environmental conditions is called a corrosion, right? So rusting of iron is the example of corrosion, and it is the common phenomenon when iron directly in contact with either water and oxygen or else both, right? Whenever this iron, the material whichever shown here, can be inserted. If you observe, these are the pieces of magnesium blocks. This is the magnesium block, this is the one, this is the one, this is the magnesium. Small magnesium blocks are inserted in the steel boat. They are saying it is the boat, and in that magnesium was inserted. Magnesium does not completely cover the steel. We are not going to completely seal with the magnesium, rather a small pieces are inserted. Now this is about the entire process what they are doing. Now the question is, explain how the magnesium blocks prevents the iron from rusting. How magnesium is preventing rusting, though it is not completely covering the entire surface, but still this magnesium is showing its protective activity against the rusting of iron. It used to prevent the corrosion process of iron. Rusting can be prevented whenever magnesium inserted like this as a block. So let me explain with this. The process is said to be sacrificial anode. Sacrificial anode stands for, it used to give the cathodic protection. So cathodic protection means, so whatever metals, whatever two different metals are present, if one is acting like an anode, second is acting like a cathode, always anode will be corroded, cathode will be protected. Okay, so if you take iron alone and it is in contact with water and oxygen, iron is experiencing anodic nature, and water, oxygen are the cathodic. Cathodic tendency naturally have the strong electron pulling nature. It strongly absorbs the electrons, demands the electrons from iron metal. That's the reason why rusting of iron by loss of electrons are possible. But whenever magnesium is inserted over, magnesium is of higher negative electrochemical potential in comparison to the iron, so that iron is becoming cathode, that magnesium is becoming anode. Who will sacrifice now? Obviously anode will sacrifice. Anode always involved in the corrosion process. That is called a sacrificial anode. Magnesium is becoming anode and entire iron ship is becoming cathode, so that cathode iron will be protected, anode magnesium will be corroded. So this is the method called sacrificial anodic protection. Itself, this magnesium is becoming anode because of higher negative potential, and iron is becoming cathode, so that which entirely protected. Always cathode will be protected, will not lose the electrons. This is the way we can prevent rusting of iron by sacrificial anodic process. And this is the kind of pipeline you can notice. If it is covered with any, if this pipeline is made up of iron, if it is coated in certain blocks of either zinc or else magnesium, any higher metal than the iron, so that this small block of metal is becoming anodic and the entire pipeline is becoming cathodic, never cathode will be corroded. So that wherever small blocks of zinc is there, small blocks of magnesium is there, that will be corroded. The entire pipeline will be protected. Move on to another application. They are saying sailing ship in the water. So this sailing ship is made up of what? Purely iron, and it is in direct contact with water in the saline or marine region. right? So many salts are there, so many minerals are present in the water, sea water, all entirely becoming like a cathode. And sea water having tendency of cathodic, this iron metal will lose the electrons, so that iron will be corroded. But what we are doing, let me insert small piece like this. If I am going to insert small piece of magnesium, whenever magnesium is inserted, magnesium is a higher potential, the entire ship is becoming cathode. The small piece of magnesium patch what we are inserted will become anode. Anode will be corroded, the entire ship cathode will be protected. This is the way we can answer the question. Because of sacrificial anodic nature, the entire ship is becoming cathode, so that it will be protected. So this is application oriented question. Move on to question number 3. Question number 3 collected from JEE Advanced 2018 question paper 2 question it is. And it is the part of electrochemistry problem. Consider the electrochemical cell. So I think everybody aware about how to write the cell notation. Always anode is represented, anodic ionic solution is represented, left hand side. Cathode is represented, cathodic ionic solution is represented. Both the half cells can be bifurcated with the double vertical line which indicates salt bridge, right? Anode represented with A, that is a solid one. Anodic solution is aqueous dissolved in water, and it is the 2 molar solution. Cathode is made up of B, which is again a solid, and it dissolved into its cathodic solution B plus 2, whose molarity is 1 molar, and again it is aqueous solution dissolved in water. This is the way cell notation is provided. The value of delta H naught, change in the enthalpy, change in the standard enthalpy. H naught denotes a standard value. Under standard conditions, the value is depicted, which is called a standard enthalpy. Change in standard enthalpy for the cell reaction is twice the rate of change in the Gibbs free energy. Change in the standard Gibbs free energy. What they are saying, delta H is twice when compared to delta G value. And the temperature mentioned as 300 Kelvin. Temperature is constant. If the EMF of the cell is 0, cell EMF is 0, cell is not producing any EMF, voltage is not generated. Delta S naught, nothing but change in the standard entropy. Entropy is the measure of disorderness. Change in the standard entropy, joules, Kelvin inverse, mole inverse can be taken of the cell reaction per mole of B formed 300 Kelvin. Delta S value to be calculated. Again, temperature is mentioned as 300 Kelvin only. Right. The data is provided for our convenience to solve the problem. Ln2 value is 0.7. Universal gas constant R value is 8.3 joules Kelvin inverse mole inverse. Enthalpy, entropy, free energy, or enthalpy, entropy, and Gibbs free energy respectively. Whatever terms we mentioned, all are represented with their own terminology. The expected answer is minus 11.62 joule Kelvin inverse mole inverse. This to be answered, this to be achieved. Let's see how can we solve this problem. Okay. In order to solve this problem, again, let's represent the cell notation. A, which is in contact with AN plus 2 molar solution aqueous, and B solid dipped into the B2N plus aqueous 1 molar solution. This is the cell notation. Anode, always left hand side material is the anode. A is converted into AN plus. AN plus means what? This entire is releasing n number of electrons, so that it is becoming n plus. Okay. So being it is a 2 molar solution, let's multiply with the 2. Entire left hand side half cell, anodic half cell is multiplied with the 2. Then cathode is depicted as a always cathode having tendency to seek the electrons. So here B2N plus having natural tendency to accept 2N electrons, so that it converted into metallic B. If you write the entire equation, left side terms left side, right side terms right side, common terms get cancelled. Left side what we have, when entire equation multiplied with 2, it will become 2A. then B2n plus will be there, 2 electrons, and here it will become 2 electrons, no? So that let me cancel out electron, electron. Released and accepted got cancelled out. Then right hand side terms are here 2 multiplied with a to the power n plus, so that it is 2an plus, and the leftover will be b. This is the way entire overall cell reaction will be represented. After writing this one, let's apply Nernst equation. What is Nernst equation? E cell is equal to E naught minus RT by 2NF ln Q, right? E cell is the EMF of the cell. E naught is the standard electrode potential. R is the universal gas constant. T is mentioned as 300 Kelvin temperature. 2N is nothing but valency of that one. And F is the Faraday. Next is the ln value. Q can be taken. Q is nothing but Q is a concentration quotient. Then what they said, in this entire reaction, EMF of the cell is calculated as 0. So that E cell is equal to 0. E naught standard value don't know, minus R gas constant, universal gas constant is known to you, that is given as 8.3, 8.3 value. T is the temperature is mentioned as 300 Kelvin, and 2n means number of electrons released accepted are given as 2n electrons are there. That's why 2n electrons mentioned. Faraday value, right? So this Faraday value 96,500, that is constant always. 1 Farad is equal to 96,500. ln a to the power n plus whole square by b to the power 2n plus. This is the way we can represent an plus. So if this is the product side, no? So product side, what we have, a to the power n plus, product concentration by reactant concentration can be taken. Product is a to the power n plus will be there, and 2 coefficient will become a square like this. And the reactant side we have b to the power 2n plus 1. Why can't we represent this b and 2a? Because unionized substance doesn't impart any concentration. Whichever compound unionized, it is not required to represent. Ionic substance only responsible for the concentration. Unionized concentration is taken as 1 as the value. So that product concentration by reactant concentration we mentioned. Okay. So here E naught will taken this left hand side. Whenever E naught is going to left hand side, that will become minus E naught. Left side minus value is there, right side also minus value is there. What we can do, we can compensate, so that E naught is equal to RT by NF ln 4. Why it is taken as ln 4? A to the power n plus by b to the power a to n plus is taken as 4. The value, consider the electrochemical cell and cell reaction. ln2 value is 0.7 is given. Then ln4 product concentration by reactant concentration is calculated as product means a to the power n plus, a to the power n plus a to the power n plus concentration is mentioned as 2 molar solution here. So that let me take a 2 molar solution can be taken square. 2 to the power 2, that will become 4. Then b to the power 2 n plus concentration is mentioned as 1 molar solution. That 1 molar solution, if you are putting in the denominator 4 by 1, it will become 4 only, no? So need not to go for 4 by 1. Then this is the way concentrations can be mentioned. E naught is equal to RT by 2NF ln 4. Okay. After getting this one, we have the Gibbs free energy equation. This is already known. This is the already familiar equation. Delta G naught is equal to minus 2 NF E naught. Delta G naught is equal to minus 2 NF E naught. Here minus 2NF E naught. E naught is equal to the standard electrode potential is equal to, already we got this value. Just we can put this E naught value in this equation. What it will become? That is RT by 2NF ln 4. RT by 2NF ln 4 can be substituted for E naught. After substituting this one, what we will do here, 2n values are common so that you can cancel out. Whenever 2n got cancelled out, Faraday, numerator, denominator, you can cancel out. Faraday cancelled. Only the leftover thing is minus RT. So whatever denominator terms entirely got cancelled, minus RT ln4 will be left. That is for what? Delta G naught is equal to. Change in the standard Gibbs free energy is equal to minus RT ln4. And we already know that according to the thermodynamics law, delta G naught is equal to delta H minus T delta S. This is the standard equation. Gibbs free energy is equal to change in the enthalpy minus temperature into change in the entropy. Delta H minus T delta S, this is the known formula. What we will do, let's substitute here. Here, delta H naught, what they said, within the equation they mentioned that the value of delta H naught for the cell is the twice that of delta G naught. Whatever delta G naught is there, the delta H naught will be twice. So that let me put, so whatever they said that will be mentioned in the quantified value. Delta H naught is equal to twice of delta G naught, right? So twice of delta G naught minus T delta S. Okay. Now, if you want to put like this, T delta S is equal to delta G naught. 2 delta S is equal to delta G naught it will be. Okay. Then delta S is equal to delta G naught by T. Delta G naught value is known to you, that is minus RT by ln4. Minus RT by ln4 by T. T remains same. Okay. If you observe clearly, in the numerator temperature is there, denominator is there, cancel out. The leftover thing is minus R ln4, minus R ln4 will be there. Okay. So if you are writing minus R ln4, minus R value is, R is the universal gas constant whose value is, here it is mentioned as 8.3. So let's put minus 8.3 into here, 4 can be written as 4 can, you can write 4 as ln2 to the power 2. Whatever power 2 is there, power 2 can be taken in front of ln. So that 2 ln2 you can write. 2 ln2, how can we convert? Ln2 value is also given. Ln2 value is 0.7. So that 2 ln2, 2 into 0.7 you can simply write. Whenever you are writing minus 8.3 into 2 into 0.7, if you multiply all the things, minus 11.62 joules Kelvin inverse mole inverse is the answer. It is purely depending upon the Nernst equation and application of thermodynamic laws. So it is interrelated, not purely related with the electrochemistry, not purely related with the thermodynamics, but it is the interrelated topic. So that we have to get the concept regarding all the branches, then only we can combine all the formulas and we can finally achieve the answer. Somewhat a critical question I can say. First of all, we have to apply the Nernst equation. After getting the Nernst equation, we can achieve a standard electrode potential value. Later on, we have to go for Gibbs free energy formula and substitute the value of E naught, and we will get a delta G value. After getting delta G, again applying delta G is equal to delta H minus T delta S, so that we will get all the numeral values. So finally we will get the final answer will be change in the standard entropy value of the cell, that is calculated as minus 11.62. For question number 3, minus 11.62 joules Kelvin inverse mole inverse is the correct answer. This is the way we can answer. Move on to question number 4. Question number 4 is somewhat simple question, and I can say it is given from the inorganic chemistry, and in particular coordination complexes. Coordination complexes is much weightage containing sphere in the entire intermediate syllabi, and in addition to this one, chemical equilibrium. Chemical equilibrium is also the kind of concepts which are having high importance in this intermediate chemistry, right? So list 1 complexes can be mapped with list 2 complexes, so that we will get the correct answers. Hybridizations are provided and the corresponding complexes are provided. If you know the concept of Strong field ligand, weak field ligand, high spin complex, low spin complex, hybridization. If these things are known to you, this is obvious to map what hybridization, what complex we can go for. Okay, the correct answer is P with 6. DsP2 hybridization is given for nickel tetracyanide -2. And Q with 4. sp3 hybridization is given for iron tetrachloride -2 anion. And R with 1. sp3d2 hybridization for iron hexafluoride -4 ion. And D2sp3, this is the inner orbital complex. 2 and 3 both means titanium triaquo trichloride complex, chromium hexamine complex, both are with the D2sp3 hybridization only. Okay, so in order to get these answers, first of all we have to go for how can we achieve this hybridization. Okay, iron F6-4 is the negatively charged complex ion. Whenever fluoride ions are there, fluoride ions are said to be what? Weak field ligands. And iron is of 3d6. 3d6 configuration is there. And weak field ligand it will be. So if you observe clearly, 6 negative charges and -4 charge is there on the iron. So that iron is in +2 oxidation state. When iron is in +2 oxidation state, what happens? 2s electrons will be removed. The leftover will be d electrons. How many are there? 6 d electrons are there. If you write 6 d electrons like this, being it is the fluorine is the weak field ligand, all the electrons are remaining unpaired, will not be paired up. And whatever 6 fluorines are giving 6 electron pairs, all are accompanied with the outermost shell. Outermost shell is going to be filled like this, and we will get sp3d2. Outer shell is going to be filled. It is not d2sp3. We have to observe clearly. sp3d2 configuration is accompanied over. So sp3d2 configuration is an octahedral complex. You can clearly notice iron surrounded with the 4 + 2, 6 ligands over, and the entire sphere is noticed with the -4, being it is the anionic complex ion. So that sp3d2 hybridization is the correct answer for iron hexafluoride -4. If you go for titanium, H2O taken thrice, Cl3 3d1. Titanium is of atomic number 23. Whenever atomic number where it is, where can you notice that this is the titanium complex? You can clearly observe scandium, vanadium, titanium. 23 atomic number will be there. Whenever 23 is the atomic number, outermost shell is having 3d electrons and 2s electrons will be there. And this is the complex which is accompanied by Cl3. Cl3 means what? Let me push out 2 electrons from s orbital, and d electrons also removed. Whenever d electrons also removed, you can left with 3d1 electronic configuration. And the entire complex, if you observe the ligands, chlorine and water are said to be weak field ligands, so that the electron is unaffected. This electron will be unaffected, and d1 it is, though it is the weak field ligand, all d orbitals are not filled, right? So that 2 d orbitals will be consumed from 3d only, and 4s 4p orbitals got combined, so the d2sp3 configuration. Though it is the weak field ligand, it is not giving sp3d2 hybridization, rather d2sp3. That is purely because of empty orbitals are there. We are not having completely filled d orbital. So the d2sp3 is the right representation for titanium complex. If you go with chromium, chromium atomic number is 24, no? So that 4s1 3d 5 electronic configuration will be there. If you observe +3, so chromium is accompanied with +3. If +3 is there, what we have to do? Let's see that chromium complex. Can you find a chromium complex anywhere? This is nickel complex, this is iron complex, this is nickel complex. Okay. So this is the chromium one. Chromium atomic number is 24. So means 4s1 3d pi electronic configuration will be there. Whenever 4s1 3d 5 electronic configuration plus 3 oxidation state around the central chromium, remove 3 electrons. S1 electron and d5 2 electrons will be removed. Whenever 2 electrons removed from d orbital, left over will be 3d3. 3d3 will be the possible electron count in the d orbitals. So whenever 3 d orbitals are having electrons, we need only 2 d orbitals for the hybridization which are available. So that 3d orbitals 2, 4s orbital and 4p orbitals 3 get combined, gives rise to d2sp3 configuration. So chromium NH3 taken 6 plus 3, it is the strong field ligand. NH3 taken 6 plus 3 is the strong field ligand. Ammonia is a strong field ligand. Nitrogen containing ligands are stronger in nature. So that here you can notice D2sp3 inner orbital complex will be formed. Okay, then let's go with the iron Cl4 minus 2. Whenever iron Cl4 minus 2 is taken into the consideration, iron is of 26 atomic number. 26 atomic number is having 4s to 3d6. Whenever 4s to 3d6 is there, they are saying that four four negative charges are there, and these four charges 2 compensated with this minus 2, and leftover iron charge will be plus 2. Whenever plus 2 charge is there on the iron, what happens? 2 electrons from s orbital got removed. When you are removing 2 s electrons, 3d6 will be the valency shell. And chlorine is a purely weak field. So weak field means it is not having enough strength to combine. All the electrons got individually occupied. So FeCl4, can you find? Yes, here is the electronic configuration. So where weak field ligand is there, that weak field ligand is used to accompany 1, 2, 3, 4, 5, 6. D6 configuration, no? So that 6 electrons are arranged in this manner. But how many ligands we have? 4 chloro ligands are there. 4 chloro ligands are giving 8 electrons. The 8 electrons can be accommodated in 1, 2, 3, 4, 5, 6, 7, 8. So that hybridization belongs to sp3. Iron tetrachloride negative 2 belongs to sp3 hybridization. This is very clear, very simple. Because of 3d6 and weak field, all the electrons are unpaired only, and incoming 8 electrons from the chlorine ligands are occupying 4s orbital and 4p orbital. So that sp3 hybridization only. If you go for nickel tetracarbonyl, nickel electronic configuration, most of the people are aware. Nickel is of 28 atomic number, 3d8 system it will be, and 4s2 will be there. If carbonyl groups are there, always oxidation state around the central metal will become 0. Whatever the metal carbonyl, that carbonyl neutral ligand, that's why metal oxidation state will become 0 around the central metal. Okay. Whenever nickel tetracarbonyl was taken, what happens? So being a carbonyl is a strong field ligand, everybody aware. Carbonyl is the strong field ligand, so that the s electrons will infused into the 3d orbital, so that s orbital is free for hybridization, and 4p orbitals, 4p orbitals are also vacant. Now it became 3d10. Whenever 3d10 is there, how many carbonyls are there? 4. 4 carbonyls able to give 8 electrons. 8 electrons accompanied in s and p orbital, so that sp3 hybridization. Just like iron tetracarbonyl, here also you can notice sp3 hybridization in the nickel tetracarbonyl. Nickel tetracarbonyl is having sp3 hybridization. Move on to next one, nickel tetracyanide minus 2. Okay, again we can go for nickel tetracyanide. Nickel tetracyanide minus 2, in that nickel is in plus 2. Nickel plus 2 means 2 s electrons to be removed. Whenever 2 s electrons removed, cyanide, what is the nature? Everybody aware, Cn is a strong field ligand. It is very strong. Whenever cyanide is very strong, the electrons individually present can be paired up. Whenever electrons got paired up, 1 d orbital and s orbital, 3p orbitals are vacant. At that condition, dsp2 hybridization will be accompanied. So nickel tetracarbonyl is sp3, whereas nickel tetracyanide -2 is a dsp2 hybridization. dsp2 is accompanied with the square planar geometry. If you notice, this is a square planar geometry, and nickel is having 4 cyano bonds in the plane. Within the plane only bonds are localized, and dsp2 hybridization is given for nickel tetracyanide -2. Let me recall once again. dsp2 is given for nickel tetracyanide -2. sp3 is given for both. One is nickel tetracarbonyl, iron Cl4 -2, both are having what? sp3 only. sp3d2 outer shell configuration is accorded for iron hexafluoride -4. d2 sp3 for both. Titanium H2O taken 3 Cl3, chromium NH3 taken 6. Both are D2 sp3. What difference you can notice? Outer shell, inner shell configuration. sp3d2 is called outer shell hybridization. d2 sp3 is called inner shell hybridization. This is the way we can go for the answer, and that will be the C. For question number 4, option number C will be the correct answer. Move on to question number 5. Question number 5 collected from Telangana MSET examination 2022. If the frequency of electromagnetic wave is 3 into 10 to the power 17 hertz, then it corresponds to which part of electromagnetic spectrum? Here, electromagnetic frequency is provided. So before going to discuss about this segment of electromagnetic radiation, first of all we have to know the concept of electromagnetic series. Electromagnetic series is nothing but, if we see the universe, there are different kind of light species are coming in a particular scalable values. Okay, so there is a certain kind of decreasing frequency, decreasing energy, increasing wavelength values. If you arrange all the magnetic rays in accordance with their decreasing energy values or decreasing frequency values or increasing wavelength values, that is said to be electromagnetic series. So all the electromagnetic lines are nothing but the light or the energy which is having two vectors. One is said to be electrical vector and second is said to be magnetic vector. Electric vector and magnetic vector both are perpendicular to each other. Perpendicular in the sense both are right angle to each other. That electromagnetic radiation having different segments in accordance, that stratification was made based on their energy, based on their frequency, or else based on their wavelength. Three parameters are there in order to classify them, so that in that entire sphere of electromagnetic series, they are given with a segment with 3 into 10 to the power 17 hertz. This is in terms of frequency. If this is the part considered, where this part is laying, there is a part called visible region, X-ray region, microwave region, gamma region. The correct expected answer is X-rays. Let's give a detailed justification for this kind of answer. In order to get that one, this is the entire electromagnetic spectrum. All the scale is mentioned with this frequency values in the hertz or else wavelength values in the meters. Okay, so they're asking for frequency, so that let me consider the upper scale, this upper scale to be considered. This is the possible wave of light. Light always propagating. Light is having dual nature. One is particle nature, one is wave nature. If you consider wave nature of the light, that wave nature is having different segments like this, right? So if you are observing 10 to the power 24 or else 10 to the power 22 or else 20 to the power 20, all these are the segments which lays in gamma rays region. Okay, 10 to the power 20 to 10 to the power 18, 10 to the power 16, in between region laying in the area of X-rays. They're saying that 10 to the power 17, within the problem they mentioned 10 to the power 17 hertz. 10 to the power 17 is the part of what? X-rays only, so that we can say X-rays is the correct answer. If you move on to 10 to the power 16, that is said to be UV visible region. Visible is called VIBGR, as corresponding to the 7 colors of light. And here you can notice infrared radiation will be there, laying in between 10 to the power 14, 10 to the power 12, and around 10 to the power 10, microwave radiation will be there, 10 to the power 8 to 10 to the power 6, that is called radio or TV. Television radiation, and 10 to the power 6, 10 to the power 4, 10 to the power 2, long radio waves will be accompanied. This is the way the entire scale of electromagnetic series is mentioned over in that. The exact 10 to the power 17 hertz corresponds to X-rays. For question number 5, option number 2 is the correct answer. This is another question, we can say last question of the session, and it is the problematic session which is collected from atomic structure. A particle of mass 4 into 10 to the power minus 27 kilograms is moving with the velocity 3 into 10 to the power 5 meter per second. The de Broglie wavelength associated with the particle is. So this is the question related with the de Broglie equation, and the Planck constant value is provided, that is standard value 6.6 into 10 to the power 34 joules second. If you know this, velocity is known to you, mass is known to you, Planck constant is known to you. So that we will put all these terms in a de Broglie wavelength equation, so that we will get the value of lambda. So that de Broglie equation is equal to lambda is equal to h by mv. Directly they are asking for the wavelength only. The de Broglie wavelength associated with the particle. The wavelength only they are asking for. So the direct formula we can use over here, h by mv. Lambda is equal to h by mv is the de Broglie equation. H denotes Planck constant, whose value already given within the problem. And m is nothing but mass in kilograms. V is nothing but velocity in meter per second. So here the value mass is given in kilograms itself, and the velocity given in meter per second only. Everything is very clear to you. Let's put h value, that is 6.6 into 10 to the power minus 34. M is 4 into 10 to the power minus 27, and v velocity is 3 into 10 to the power 5. If you put all the values here, 10 terms can be taken. So if the base values are same, so that powers can be added if same sign is there. If base value is same, powers can be subtracted if different signs are present. If you consider this principle, all 10 values can be concised into 10 to the power minus 12. So here all 10 base 10 values are there, no? All base 10 values. If base 10 powers are same, so that you can add them. If base 10 powers are different signs, so that you can subtract. Based on this principle, the entire base 10 values are converted into 10 to the power minus 12, and 6.6 remains same. By here 4 is there, here 3 is there, so multiply that 12. So 6.6 by 12 into 10 to the power minus 12, that will become 0.55 into 10 to the power minus 12. So you can write it as 5.5, and it can be converted into angstrom value, 5.5 into 10 to the power negative 3 angstroms. This is the way we can go for the calculation. For question number 6, option number A1 is the correct answer, de Broglie equation. If you know the de Broglie equation, it is obvious to go for the calculation. Lambda is equal to h by mv. Lambda is equal to de Broglie wavelength. H is the Planck constant. M is the mass in kilograms. V is the velocity in meter per second. If you substitute the values directly, we will get this value. For question number 6, option 1 is the correct answer. By this, we entirely completed the session where all the simple concepts to complicated mechanisms and included with the problematic session, each and every corner of the chemistry got covered over, and I hope this is the most interesting session and most informative for your serious preparation. And there is a question regarding the entire session, so the answer can be posted in the comment box. The question is regarding if you go for electromagnetic radiation, just we gone through the electromagnetic radiation and a scale regarding electromagnetic radiation. Can you arrange all the different segments of light in accordance with the increasing energy? Can you listen properly? Increasing energy order of electromagnetic radiation can be commented, right? So hopefully this will be really informative towards your preparation. Kindly like the channel, comment, share, subscribe, and thanks for watching.